Today, section 4.4, optimization. This is one of the main sections in the first part of calculus where we're doing derivatives, and it's one of the most powerful things that derivatives were designed to do, which is to find optimum values. So optimum just means best. So I went ahead and laid out the homework, which is page 226, number 1 through 19 odd. And then I'm just going to go through a bunch of examples, and you just start doing the homework whenever you think you get it and come back and look at more examples if you need to. So there's going to be page 226, 1 through 19 odd. There's also going to be a project, the box project, which is probably already attached to these videos. All right, so first, a definition of the word optimize. So optimize means to find a maximum or minimum. So basically it's like extremum. It just means either a max or a min, but depending on the problem, the optimum value. So optimum is Latin for best. So Optimus Prime, his name means best first. Prime means first. Optimus Prime. Optimus means best. Best first. Optimus Prime. I don't watch Transformers. To optimize means to find the best value. So the best value might be a maximum or might be a minimum depending on the problem. So if I'm solving, if I'm just writing an equation that describes infection rate of a virus depending on mask use, I probably am looking for a minimum value because I want the infection rate to be minimum, unless I'm an evil person and I might want it to be maximum. And if I'm talking about profits of a company, I want the profits of a company, the best value is going to be maximum. Interestingly, whether I'm good or evil, I want the maximum profit for my company. All right, you can think about the ethical implications on your own time. Meanwhile, I will start looking at examples because all it means is finding maximum minimum value. So we already know how to do that. So it's just a matter of transferring this into an applied situation. But the applied situations get kind of complex. So I've attached to these videos something I wrote up a while ago, which is my magic steps for solving an optimization problem. I invite you to print this out because it's not always going to fit on the screen all the way. All right. So there are 7 steps, my 7-step method for solving an optimization problem. Number 1, find an equation for what you are trying to optimize. That is often the most difficult part. Sometimes it's hidden, so it's tricky. 2, find an equation relating one or more variables of the problem. That can also be difficult, okay, because you're going to end up with problems that have multiple variables. You can have lots of variables, but we're still only doing single variable calculus. So you need to find equations relating the variables so that you can end up with an equation in just one variable so that you can take the derivative. So that's why step 3, we substitute whatever we get for equation 2 into equation 1 to obtain a single equation in 2 variables. So like y is a function of x. All right, that's what you're going to be after. Otherwise, you can't really do a derivative. All right, so that's setting you up to do step 4, which is find the derivative of the equation. Step 5, everything else here is just finding extreme values. Set the derivative equal to 0 and solve. Step 6, use a derivative test. And generally, you can use second derivative test or first derivative test, whichever one's easier, to verify that you've found a maximum or a minimum. Because sometimes you'll find a critical value. You wanted a maximum, but you actually found the minimum. If you're supposed to be reporting the arrangement of a company that's going to create maximum profit, and you accidentally report the value that gives a minimum profit, you will lose your job. So number 7 is read the question again to see if you need to solve for any remaining variables, because sometimes the problem has multiple variables. We have to solve for different ones. All right, so our optimization problem, optimize means to find a maximum or minimum, the optimum value, the best value of a function that describes an applied situation. Now our first example, we're just going to be cranking through page 226. And you're going to do the odds and I'm going to do the evens, but sometimes I'm going to do your homework for you. In fact, in this one, number 1 has part A and part B. I'm going to do part A, you're going to do part B. Okay, because part B is harder. I want to do the easy one. All right, so it says, find the sum of two, it says the sum of 2 non-negative numbers is 20. Find the numbers if the sum of their squares is as large as possible, as small as possible. So note there's 2 different questions here. Part A has 2 different questions. Part B has 2 different questions. Number 1 requires 4 answers with complete justifications. All right, I'm going to start the first one for you. So here we go. We're going to do page 226, number 1, part A. And we're going to start that in the next video, so these videos don't get too long.